So let's take a look into the history of astronomy and how it relates to you and me and everything around us today. One of the big questions is, what is astronomy? We already talked about astrology, but with astronomy, we're dealing with science. We're only going to look at testable predictions or hypotheses, things that we can measure. Just making up stories isn't good enough anymore. The earliest roots of astronomy we talked about a little bit. Um, Ancient people looked at astronomy as something mystical and supernatural beyond themselves. Supernatural just means beyond the earth, beyond normal, beyond natural stuff. And when they looked up in the sky, it was just something up there that was different. So supernatural kind of made sense. There's a field called archaeoastronomy, which is the study of ancient astronomy, how cultures dealt with that. And one thing that we can see is that there were cultures all around the world that spent a lot of time and effort studying the skies. It was really important to them. Places like Stonehenge in England, they put a lot of effort into moving and structuring these stones to mark the sky. And it's very obvious that they really truly were marking the sky. There was a farmer in Germany that was, forgot the word, plowing his fields, and he noticed these funny little circles in his field that formed a pattern. And rather than just dismissing it, he talked to somebody at the local college, and they came down and looked at it and realized that he found some sort of structure that was old. And archaeologists came to it and started studying it, and they realized that it basically was Stonehenge, but made of trees. And he found the remnants of the trees in the soil. And when they laid it all out and rebuilt it exactly as it stood, that's when they realized that, hey, this is just like Stonehenge. And it was much older than Stonehenge. So that one was made of wood, so we're lucky we found it. Stonehenge, of course, is still there. In the Mayan city of Chichen Itza, there is a temple. And in this temple, the part that's not ruined and destroyed, you can look through these holes in the wall and you can see important dates, if you will, when Venus does certain things, when the equinox happens. This was their calendar, and it's important enough that they spent a lot of time and effort into doing this. I spent my honeymoon in Tulum, actually north of that a couple hours, but we went to Tulum in Mexico. And part of the city, oh yeah, there's some cool stuff going on here. At the top of this pyramid, I remember we were standing there at the bottom of the stairs, and the guy said, if you look up, you can see this little structure at the top of the stairs. We said, yeah. He says, yeah, that's where they did the human sacrifices. So it was quite interesting. And when archaeologists first discovered Tulum, they noticed that there was a seat in the wall, but it was facing in. So that first led them to believe that it was a guard and that this was some sort of prison place. But that was the only evidence they had. There was just nothing else that said that. One day, one of the archaeologists woke up in the morning, wandered up and sat in the seat, I guess drinking his coffee, and it just happened to be the, I guess the spring equinox. Well, it doesn't matter which, we'll talk about that. And he was shocked because they already knew about this archway on the other side of the city and they didn't know what it was for. As he was sitting in the seat, the sun rose through the arch, and they realized that the arch and the seat were nothing It wasn't like the seat wasn't a prison guard location or anything. It was an astronomical observatory. So we have seen this. We've seen structures where people have marked calendars and things in the sky on bone, but that stuff is kind of hard to find. Things are hard to find partially because of us. The Spanish conquistadors burned all the Mayan books they could find. Only 4 books survive today. One of them, well, it wasn't a book, was that Mayan calendar that ended in 2012 that freaked everybody out. But if we jump ahead a little bit, we start talking in more detail about the astronomy of Greece. Greece came from the earlier cultures of Babylon and Egypt, but we know a lot more about the Greek astronomy because their documents have survived. And again, when I say documents have survived, it's only a tiny fraction. They had a huge collection in the Library of Alexandria, which is in present-day Egypt, which burned down, and very, very little was saved. What we do know comes from those texts that were saved. Little things like Plato writing about the city of Atlantis. Everything we know about Atlantis is part of a paragraph, or maybe a couple paragraphs, of a scrap of parchment or scroll that Plato wrote down. That's all we know. And of course we have entire movies and stuff based on Atlantis. So yeah, we don't know much, but what little we do know is quite amazing. If you remember maybe physical science, your teacher probably taught you that there was some American or British guy, I can't remember which, that invented the steam engine. That's wrong. There was a Greek guy 2,500 years ago by the name of Hero, Hero. He invented the steam engine, and it actually kind of looks like a little jet nozzle. And you would boil some water, it would push steam out one side and cause the mechanism to spin. And to the Greeks, it was a cute little toy. If anybody had thought to put a pulley around it and make it pull up a bucket out of a well, we would have had the world's first steam engine, like use of a steam engine. And who knows, maybe we'd be in flying cars by now. What we do know is that the Greeks tried a completely new approach. Instead of studying it for religion and astrology, they tried to understand the universe. As far as we know, this was the first culture that believed that they could figure out the universe, what other cultures called supernatural. The Greeks said, it's within reason, we can do that, we can figure it out. So let's see where curiosity brought us. There was Thales of Miletus. I do not know how to speak Greek. I don't know if I'm pronouncing him right. But he was one of the first to write down, or that we know of, again, from the scrolls that were left from the Library of Alexandria. First one to believe that humans could understand the universe and how it works. It's not just a mystery. We'll leave it at that. You might recognize the name Pythagoras, who invented the Pythagoras Rex theorem. And he noticed these cool mathematical patterns in nature. He knew about octaves and 8 notes. He believed that much of the universe could be solved by analyzing the math, which is what we do today. His math was musically oriented with the notes. He believed that there was a music, a mathematical pattern of music that caused the sky to move, that directed everything. One name for the sky is the heavens. Sometimes you will hear people talk about the music of the heavens. That's a direct nod to Pythagoras, who was trying to use mathematics to figure out the heavens and the universe. They didn't have a lot of technology. They could only observe what they could with the eye. So they were kind of left to their imagination with a lot of it. But it was a really great start. Plato had this really cool thing. If you want to look up Allegory of the Cave, I can't remember how short it was. We had to read this in college. I'd say it was an essay kind of thing. And in it, there are two prisoners chained to a wall in a room, and in the next room, there are prison guards with a fire going, and they're cooking and talking. The weird thing is, the prisoners come into the story with no recollection of anything, although they can speak English. Well, no, I guess it'd be Greek. They can speak, and they can understand, and they can see. But since they're chained to the wall in such a way, all they can see is the wall in front of them. And while they're there, they can talk to each other, and apparently they've got fully developed language and can question, what is this thing on the wall? And they start seeing shadows, which we know are from the soldiers, maybe walking in front of the fire. And they hear the soldiers talking, and they develop this big mythology behind the shadows and the noises, and come up with this really bizarre story because that's all they know. Plato believed that our reality is just like that we only see a shadow of the universe, and our understanding is so limited that we kind of make up our own mythology. And that idea stuck for a long time. Since then, we've come up with the fact that measurements are something that is repeatable by multiple people in different areas and different times. So we tend to latch on to measurement as fact and not just, look at it and say, well, this is just the way we see it. Maybe when we die, we'll see it differently. So that one came from Plato. One interesting thing that Plato believed is that the perfect form of the universe was a circle. In fact, in a lot of modern wedding ceremonies, they talk about the wedding ring as a symbol of perfection because it's a circle. And that concept led to something interesting because everyone believed that stuff up in the sky moved in circles. And Plato thought that that was a form of perfection. For thousands of years, people believed that the heavens, what you call outer space, the stars, the moon, the sun, people believed that the heavens moved in perfect circular form. And that comes into some modern things. We also had Aristotle, and you've heard of one of the things that he did, where he basically divided the universe into two parts, Earth and the heavens. To him, it wasn't a religious thing. Earth was where we are, and the heavens was up there. They were just two places. To him, they were totally different. If you had said, I went to the moon and got a moon rock and brought it back, he'd be like, seriously, dude, there's no rocks on the moon. It's heaven. It's a different thing. There's no correlation between the two. He believed that the universe was geocentric, which literally means centered around the Earth. The Greeks did a lot. They figured out the size of the Earth. They figured out relative distances to the Earth and the moon and the sun. But they missed the little concept that we go around the sun. And their thinking was that, well, since they had calculated a lot of this, they would have known that the Earth spinning around and then going around the sun would have been so fast, they thought they would have felt the motion as if you were on a ship or a horse. What they didn't know is about inertia, that everything just kind of keeps going. If they had fast-moving cars where you sit in the car and you toss a coin in the air and catch it, it doesn't slam into the back windshield, it moves along with you. if they had seen that simple observation, which they could have done from a ship by dropping something from, if they'd, well, talked to a sailor. Sailor's up on top of the mast and he drops something down below. They don't have to throw ahead for the boat to catch up. They just drop it, and the boat and whatever they dropped are moving. If they had caught that, they might have realized that the universe was not geocentric. Kind of an interesting thought. Aristotle argued that Earth was not moving because of those things, but also because he saw no parallax. Parallax is pretty cool. One of my kids was in the back of the car, in the back seat when they were little, and I heard this whoa from the back seat because they had discovered parallax. They didn't know it. So what you want to do is take your thumb, hold it in front of you, and close one eye. Switch eyes, and you'll notice it changed position. But your thumb didn't change position. It's just how you observed it. The parallax my kid noticed was they held up their hand, and with one eye they can, of course, quote, see through their hand. That was pretty exciting to a 3 or 4-year-old. It's all about the observer. Parallax is apparent change in position of an object due to the change in location of the observer. It's not the object that moved, it's the observer. This actually allows you to judge distance. If you've ever tried to catch something with one eye closed, you can't. It's kind of hard. If you've seen the movie Christmas Story, the one that's on Christmas Day all day, and I guess the what do you call the money that they get for stuff? The word rewards is stuck in my head, but okay, whatever. I guess those have expired and they can play it. Royalties, that's it. So in the movie, he got his eye shot out with the Red Ryder BB gun. The exact same thing happened to me in high school, and it was a Red Ryder BB gun. And I had several surgeries and can now see 20/20 with that eye with glasses, but it's no longer nearsighted, it's farsighted and really messed up. But anyway, when I was in high school, my first job was at Chick-fil-A, and almost about a year or two, I was blind in my right eye until they did more surgeries. And whenever I needed register keys, all my coworkers caught on real quick that, hey, Lanham can't catch, because I couldn't figure, I had one eye, I couldn't see anything. So, I put my hands up and tried to catch something 2 or 3 times, and I couldn't do it. And then I was telling the eye doctor, and he laughed, and he was like, do you know about parallax? No. And he said, yeah, just move your head, which is the same thing as having closing one eye and opening the other, and your brain calculates that automatically. It's kind of cool. So, okay. Aristotle said if the Earth were moving, we would see the star positions changing, much like in the picture, the thumb and the house and the trees. We would see things change simply because the Earth is moving. If you walk around your room, although I've got this set up for classroom, but if you walk around someplace, things change relative to each other. So why don't we see parallax in the stars? It's actually fairly simple. If you want to pause it and think about it, why don't we see parallax in the stars? It's because they're so far away. Instead of holding your thumb up, imagine somebody standing at the front door of their house holding their thumb up, and you move around. That picture looks almost exactly the same. There would be a tiny bit of parallax between their thumb and their face and the door, but you'd have to move a lot or be able to detect it. And that's what things like the Hubble Space Telescope can do. But our eyes, no, you need some good equipment for that. There was a guy by the name of him. He's the one that measured the size of the Earth. We've already seen videos on it. And there's another guy, well, everybody noticed something in the sky since the ancients. There was a thing called retrograde motion. And Mars does this. Mars will travel through the sky like normal, although not normal. The Greeks noticed that all of the stars stayed pretty much exactly where they were from day to day, month to month, year to year, generation to generation. But there were some stars that didn't. They were wandering stars. The Greek word for wander, I believe, is planis, Planis, which is where we get our name for planet. Planet literally means wandering star. And some of them, like Mars, wander really weird. Mars moves through the sky on its own, like I said, like normal, but different than other stars. And sometimes it slows down and stops. And then it goes backwards. And then it slows down and stops and goes forward again. To explain this was a guy by the name of Ptolemaeus. That's it, Ptolemaeus. And he said that the planets moved around the Earth, but in a loopy-loop sort of thing. So it started to get a little complex. In fact, here is a great illustration. We have the Earth in the center, which is what they thought. And we have something like Mars, which goes in these epicycles that just loop-de-loop and spiral around as it orbits the Earth. And the dotted line there is the apparent motion of that along one of those loops. That's what we would see. This was considered the standard model of the universe until late, I think it was mid to late Renaissance in Europe. And by the way, yeah, a lot of the astronomy is Eurocentric. The Europeans, the Nation of Islam, Chinese, the Mayans, the Aztecs, they all studied this. They all did it, but not much of it remains. The Spanish conquistadors wiped out the Aztecs and the Mayans, and the Chinese. There's this deep cultural thing where I just heard it recently, and it was interesting, where the current culture is better than anything before it, and that's led to things like purges of ancient art and things. The communist government of China in the 1950s and 60s, I believe, went on, I guess, a rampage. They went on this mission to destroy anything in antiquity that could demonstrate that things were good back then. Because, you know, the communist government was supposed to be the best thing to ever happen to China. So we, and also the fact, we'll talk about this, but there's a little thing called the Little Ice Age, where the sun messed up Earth's climate and Northern Europe plunged into a deep freeze, and they scattered. They're the Northern Europeans are the ones that went around the globe and, you know, have colonies. I just read the other day that there's, I think, on average, every 6 days, there's an Independence Day directly related to England. They had so many places that every 6 days there's a country that celebrates their independence from England. It's kind of cool. You don't hear about the Italians conquering things because their climate was fine. They didn't have to go anywhere. The ancient Greek writings, mainly from the Library of Alexandria, were preserved by the Islamic nations for centuries. Neil deGrasse Tyson talked about this in the video last week. And I'm going to mention Christianity and religion, not, you know, for astrology or anything like that, but because that was the dominating government, the dominating force in Europe at the time. The early Christian church based a lot of doctrines, beliefs, on Aristotle and Ptolemaeus' view of the universe. Unfortunately, those being wrong, they ran into some trouble. A really good one is the fact that they believed that the earth was the center of the universe, and they thought, if I can find something in the Bible that says the same thing, then it must be true. And what they used is Genesis, where it says that the earth was created for man. And the supposed fact that everything revolved around the earth kind of proved that that verse was true. So they fell into the trap of trying to prove faith through science, which is never a good idea. And they had a lot of doctrine built up on that sort of thing. So by the time Galileo and Newton came along and were like, no, guys, you're wrong, there was over 1,000 years built up of a belief system that was built on the wrong stuff. So, kind of interesting. During the Renaissance, this is when the papers from the scrolls from ancient Egypt were rediscovered by Europeans, which led to the Renaissance. There was a guy by the name of Copernicus. He was a Catholic priest who came up with what is called the heliocentric model. It was against Aristotle, therefore against the doctrines that the church built up, therefore it was illegal and it was heresy. He was scared of what might happen to him, so he published it on his deathbed. There was a legal entity of the church at the time, and remember when I say church, that's the government of the time, that would do things to heretics. In some places they would, you would go to court. You literally went to court and they would try you and determine if you're guilty or not. And in some cases, you could be arrested and sit in prison for years before you finally got your trial to be proven innocent and you move on, but you just spent years in prison. And prison back then wasn't like it is today. There's, no HBO. But there were some places, I think Spain was one of them, where you would get arrested and then tortured. And if you died before you confessed your sins, well, that was your own fault for going to hell. And if you confessed but just happened to die, then well, it's okay because you're going to heaven. So that was in Spain. That was called the Inquisition. Look it up. It's interesting stuff. Galileo came along, and he was the first one to use this. Well, when I say first, the first one we know of, the first one that wrote it down. There was probably a guy by the name of Bart Simpson that did it and, didn't think anything of it. But Galileo was the first one to take this thing called the telescope and start pointing it at the sky. And he noticed some things. For instance, the moon. Remember that Plato believed that circular motion was perfection. That was one of the things that the early church took on, was that things that move in circles are perfect, and to them the Christian concept of heaven became literally the sky. You would go up into the sky when you would die, and heaven was a physical place, which we now call outer space. They didn't have that concept. But there's some issues. If you look up at the moon, you can see, well, we see the man on the moon. I think some cultures see a rabbit. There are imperfections there. And they said, well, that can't be. The moon is part of heaven. It's part of God's realm. It has to be perfect. There are no blemishes. And one of the concepts that came around is that those blemishes were reflections from Earth's oceans, because Earth is dirty and bad. And that's what religion did with the concept of heaven and Earth, the space and Earth, good and bad. So, in fact, when I was a kid, somebody told me that the dark spots on the moon were a reflection of Earth's oceans. And at that time, I remember thinking that the shapes didn't seem to match, but what was I to know? I was just a kid. But no, that's what they believed. When Galileo looked at it with his telescope, he saw what we now call craters. And that means the moon wasn't perfect. There were things going on there. And you can't dispute what you're looking at with your eyes, so, something's wrong here. He looked at the Milky Way, which is supposed to be perfection. So it was a wispy something. No, it was made of stars. The Milky Way was made of things, objects. This didn't make sense. And the biggest one of all is the whole geocentric model. Because the church spent 1,000 years or more developing the idea that Earth is where man lives and that's heaven, then everything revolves around the Earth because of Genesis, then everything in the universe revolves around Earth. Nothing can revolve around anything else. Because if you think about it, if something revolved around a heavenly object, then that object would be like Earth. And in the religious sense, Earth is bad and dirty and evil. Well, you can't have that in heaven. That's supposed to be perfect. So the concept of something orbiting something other than the Earth was basically a huge religious idea. And Galileo discovered moons around Jupiter, disproving a lot of stuff fairly quickly. Now, right now, this week is supposed to be nice and clear. If you go out in the evening after sunset, the brightest star up there, a little bit towards the southeast, is Jupiter. Get a cheap pair of binoculars, get a camera that can zoom, and look at it. That will be better telescope than what Galileo had. So I really encourage you to do this. You will see little dots on either side of Jupiter. Those are called the Galilean satellites, the 4 largest moons of Jupiter that Galileo discovered. There's 4 of them, and they follow a little line, and sometimes they're all on one side, sometimes they're scattered, sometimes they're gone because they're in front of or behind of Jupiter. And after observing for a while, he realized, yeah, Jupiter had moons. Something is orbiting something up there and not Earth, which made Jupiter more Earth-like, which was not very popular at the time. So Galileo discovered that the heavens were not so perfect anymore, and he also was brought up with in front of the Inquisition. This was the legal system. He confessed that he was wrong, but the secret was out by then. Everybody with a telescope could look and see for themselves. And he actually tried to reconcile, all of this with Christian teaching, because he was very religious. A lot of people look at him and say that he was, anti-religious. No, he was really religious. In fact, his daughter was a nun, and they wrote letters back and forth about a lot of this, about his thinking. And when he died, or when his daughter died or something, the head nun lady, I don't know my terminology, I don't know. Hey, there's the bell. They found Galileo's writing, and, oh my gosh, this is the heretics. They burned everything. So all that's left are the letters that his daughter wrote to him, and somebody put that into a book. I believe it's called Galileo's Daughter. I have not read it, but I've had several students that have, and they loved it. My mom is an artist, and she read it and loved it. I keep saying I'm going to, but I still haven't, but it's kind of cool. But yeah, so Galileo, lucky for him, did not live in Spain, because his punishment after confessing was house arrest for the rest of his life. So, yeah. So when we look at this, we can see that the purpose of astronomy has changed. It's not trying to explain this, well, it's not looking at the supernatural and trying to fit it to our lives. It's trying to understand the universe, which is actually kind of interesting because it still comes back to us. We'll learn about this, we'll get into it, but some of the people have realized that all of the atoms in your body, once we've learned this, the atoms in your body were formed at the center of stars. And that the center of stars eventually explode, spreading material throughout the universe. So Carl Sagan is the one who said, you are literally made of stardust. So we still loop around back to ourselves and see where we fit in the universe, which is pretty cool. So take a look, think about how our perspective of the universe has changed. That's your thought for today. Have a good day.